Chapter 8.1 Common Factors. Okay, for these common factors, we need to know the definition of greatest common factor, GCF. Okay, actually, the GCF among some numbers is the multiplication of all common factors. Okay, let's find the GCF, the greatest common factor of these two numbers, 24 and 60. Okay, so first of all, let's write this one in a prime factorization. So 24. We will write this one as a product. So 24 can be is a product of 2 times 12, and 12 is 2 times 6, 6 is 2 times 3. So we can write this 24 as 2 times 2 times 2 times 3. So the product of these four factors will be 24. Now let's find out the factors of 60s. 60 is 2 times 30, and 30 is 2 times 15, 15 is 3 times 5. So we can multiply all these numbers, the leaves, which are 2, 2, 3, and 5. So this will be 2 times 3 times 5. So we just wrote this one as a product of primes. And then if you rewrite it, you can do this way. 2 is multiplied 3 times, so you can write it as an exponential form. 2 cubed times 3. And 60 is 2 squared times 3 times 5. Okay, from these two expressions, we can find the common factors. Okay, the common factors. Okay, common factor is a factor that exists in each number. So here is 2 and 2 is a common factor, and next 2 is also a common factor. And for the next two, the third number 2 is not a common factor because this number is not in number 60. How about 3? Okay, 3 is in number 24 and 60. So 3 is a common factor, but 5 is not a common factor. So common factor is a factor that exists in each number. So by looking at this, the GCF, the greatest common factor, is a product of all these common factors. So 2 times 3. Then there will be 12. Okay, so we just found the common factor from this product. But how about the exponential form? From this exponential form, okay, the base 2 is a common factor because number 24 has 3 2's. 2 is multiplied 3 times. Number 60 has 2. The occurrence of the number of occurrence of 2 is 2 because 2 squared. So from this, we can select the exponent. We can the smallest exponent because there will be the common factor. Because 2 occurred twice in number 60, and 2 occurred 3 times in number 24. So the common factor is only 2. So when we have an exponential form, the greatest common factor will be the product of the same base, same factor 2. So from this, we will be 2 squared because square, the smallest exponent shows the number of common factors occurred. And then number 3, the base 3, the 3 is a common factor as you can see this, and the exponent is 1, that means just 1. Just 1. And 5 is not a common factor because 5 is not in the number 24. So the GCF will be 4 times 3 is 12. So when we have an exponential form, always select the factor that has the smallest exponent. So find the common factor. That means the base should exist in the both numbers. So if base exists in both numbers, then that is the common factor. Then from that common factor, select the smallest exponent. Okay, so let's try an example. Okay, for this example 1, 12 can be written as 2 times 6, 2 times 3. So this will be 2 squared times 3, and then a to the 4th power and b. And 18 is 2 times 9. 9 is 3 times 3. So this is 2 times 3 squared times a squared b squared times c. From this, let's find the common factors. Okay, 2 is the common factor because 2 exists in both numbers. And then the exponent 1 is the smallest one. So we will select this factor. So the GCF will be the product of 2 and 3 is a common factor. 3 is a common factor. And this one has exponent 1, so we will select this one. And a is a common factor, so 2 is the smallest one. The exponent 2 is smaller than 4, so we'll select a squared. B is a common factor, and the exponent of this b is 1. So 1 is less than 2, the smallest one, so we'll select b. And c is not a common factor, so leave it. So the greatest common factor will be 2 times 3 is 6, a squared b. 6a squared b. So let's check this 6a squared b. So as you can see the original number, okay, here is number 12 and 18. 12 and 18. So number 6 divides both 12 and 18. 12 and 18. So, there are even 2 can divide both numbers, 3 can divide both numbers, and 6 divides both numbers. So 6 will be the greatest common factor. So if you see the numbers, then you can find 6 as a common factor. And the variable a, as you see this, a squared is smaller than a to the 4th power, so select a squared. And then for the factor, common factor b, b, there's only one b, so we'll select 1b. And c is not a common factor, so leave it. So this is the greatest common factor. Okay, let's try more example. Okay, this is a problem 1 questions. Okay, there are 2 expressions, 4x to the 6th power times y. And 4 can be written as 2 squared and x to the 6th power and y. 18 is 2 times 9, right? 2 times 9. So 2 times 9. 9 is 3 squared. And then the rest are the same. So from this, we can find the GCF. The GCF will be the product of all the common factors. So we have 2 squared and 2. Then 2 is the smaller than 2 squared. So we select 2. And then 3 is not a common factor, so leave it. How about x squared and x6? X squared is smaller than x to the 6th power, so select x squared. And then y's are the common factors. Y is a common factor, so y to the 1st power is smaller than the y to the 6th power, so select the smaller one. Then this is the GCF. Okay, for the numbers, look at this number 4 and 18. Okay, 4 cannot divide 18, so 4 is not a common factor. And 2, okay, 2 is a common factor that divides both numbers, and 2 is the largest number. So 2 is the common factor. So common factor always comes from the smaller number. 4 and 18. Between this 4 and 18, the smaller number is 4, so common factor comes from this number 4. Okay, for example number 2, we will factor this trinomial. So before we do this factoring, let's try an example here. Using a distribution on the right side, get 2x times the parenthesis. This parenthesis has 2 terms. So when we do distribution property, this will be 2x times x plus 2x times y, 5. So we have an addition. We have 2 terms, which is 2x squared plus 10x. This is what we have. So from this, actually factoring is, we start from this, from the last expression, the expression, we make a product like this. That is factoring. So first of all, we have to find the common factor. So as you see this one, 2x squared plus 10x. If you see the second line, from here, we know that 2x is a common factor. We know that 2x is a common factor because here is 2x squared. 2 and from this number 2 and 10, 2 is a common factor. And then x. So here is the GCF. The GCF is 2x. Because 2 is a common factor and x is a common factor, but x is smaller than x squared. So we select x. So 2x will be the greatest common factor. So you can factor out 2x. So the first term will be 2x times x. And the second term, 10x, will be 2x times 5. So from this, factor out this 2x. So we have the first equation. The first expression, 2x times parenthesis, x plus 5. So when you take this 2x out, okay, from here, when you take this 2x out, we have x and 5 left. So factor out 2x, so it goes over here and put parentheses, then write down the leftover factors, x and 5, inside the parentheses. So from the example, okay, the greatest common factor. So the greatest common factor is what? The greatest common factor is, okay, let's look at the number. Okay, the smallest number is 5, and then 5 can divide 35 and 10. So 5 is the common factor. And how about x? Okay, we have x cubed, x squared, x. So x is the common factor, and x is the smallest one. So 5x is the GCF. So let's factor out the GCF. Okay, so factor out GCF for each term. Then the first term will be 5x times x squared. Because you took 5 out, 1x out. So there are 3 x's. So 1x out, so you have x squared. Okay, minus, take 5 out, and 35 is 5 times 7. Okay, let's take 5x out. So 5 times 7 is 35. There are 2 x's and 1x out, so 1x left. So actually x times x will be 35x squared. Okay, for the last one, take 2x out, then what we have is 2 times 5 is 10. And x went out. So we can just rewrite each term by separating it with the factor 5x and the leftover. So from this, factor out 5x and put parentheses. So we will take 5x out from each term. So for the first term, 5x went out, so x squared left over. And for the second term, 5x is out, so we have 7x left. And then for the third term, since 2x out, 5 is the leftover. So this is a product. Okay, from this trinomial, also let's find out the GCF, the greatest common factor, because we want to factor this trinomial. So look at the number first, 16, 8, and 12. So 8 is the smallest number. And 8 is not a common factor. So how about 4? Okay, 4 is a common factor of 8 and 12 and 16. So 4 should be the common factor. Okay, how about the common factor x? So there are x squared, x to the 4th power. So x is the common factor and x to the 4th, x squared is the smallest one. How about y? Okay, y exists in each term, so y is the common factor. So the common factor is 4x squared y. So we will write it as 4x squared y as the common factor, and then write the leftover factors. So 4x squared went out. So from the first term, 4 times 4 is 16, and x squared went out, y went out. So that's it. So how about the second term? Okay, rewrite the second term as a product of the common factor and others. Okay, 4x squared went out. Okay, let me write 4x, the greatest common factor in red, even the right side. Okay, so plus 4x squared y. Okay, then from the second term, 4x squared y is separated from the second term. So we have 4 times 2 is 8. X squared went out, so x squared is the leftover. And 1y went out, so 1y left. So when you multiply these two, it should be the same as the second term. Okay, for the last one, okay, 4x squared y went out, so okay, why don't we put the negative sign, leave the negative sign outside. Okay, put the negative sign outside, so we don't have to worry about the sign. Then 4 times 3 is 12, and then x squared went out, so x squared left, and 1y out, so 4y is left. Okay, can you see this? So 4 times 3 is 12, x squared times x squared is x to the 4th power, y times y to the 4th power is y to the 5th. So this is correct. Let me erase this. So this is equal to, now factor out 4x squared y, because that is the greatest common factor, and then put parentheses. So we're gonna put 3 terms. So the first term will be the leftover from the first term, so that will be 4 plus 4x squared y went out, so 2x squared y is the leftover, and the minus 4x squared y went out, so 3x squared y to the 4th power is the leftover. So this is the factor form. For this problem too, let's find the GCF of this binomial, the greatest common factor. So by looking at the number 14 and 21, 14 is smaller than these two numbers. So 14 is not a common factor. How about 7? Okay, 7 is a common factor because 7 divides both 14 and 21. So 7 should be the common factor. And a squared, a is a common factor and a squared is the smallest one. B is not a common factor, so the greatest common factor will be 7a squared. So you can write it as 7a squared minus 7a squared. So what I'm gonna do is rewrite each term so that you can separate each term with the greatest common factor. 7a squared times 2 will be the first factor, and then for the second term, 7 times 3 is 21, and a to the 4th power. So 2 a's went out, so a squared is left over, and then b is the leftover. So from this, you can factor out the greatest common factor, which is 7a squared, and put parentheses, write the leftovers. So it's 2 minus 3a squared b. So why don't I change this one to minus right here. So there are 2 terms. Okay, let's try another one, the letter B. Okay, from this trinomial, let's find the GCF for these 3 terms. Okay, the numbers are 6, 9, 12, and we know that 6 is not a common factor because of 9. Then 3, divide 6 by 2, then is 3. So let's check 3. Okay, now 3 is a common factor for all these 3 numbers, 6, 9, and 12. So 3 is a common factor. How about x? Okay, x exists on all of these 3 terms. And then x squared is the smallest one, so take the x squared. How about y? Okay, y squared, y to the 4th power. So y squared is the smallest one, smallest common factor. So we take it. So the greatest common factor is 3x squared y. Okay, let me write 3x squared y, 3x squared y, and then, okay, so from this, okay, let's rewrite each term so that it's a product of the GCF and the leftover factors. So from the first term, 3 went out, so we have number 2 left over, so 2 times 3 is 6. Okay, 2x out, so 2x left, 1y out, so 1y left. Okay, for the second term, 3 times 3 is 9, and there are 3 x's, so 2 out, so we have 1 x left. There are 2 y's. Oh, wait a minute, y squared, right? Y squared, sorry. The greatest common factor is y squared. Y squared, right? Y squared. So actually, for the first term, already 2 y's went out, factor out. So there is no y left. Even the second term. So we took y squared out, so the leftover is only 3x for the last term. Okay, factor out 3, then 3 times 4 is 12, and x squared went out, 2 y's out, so 2 y's left. Okay, then from this, factor out 3x squared, y squared, put parentheses, write down the leftover factors. Okay, that's it. Okay, let's try different factorings. This time factor by grouping. Okay, this example is related to factor by grouping, but actually if you see this, the common factor is this binomial x plus 2. So x plus 2 is a binomial factor, and that binomial factor occurs on both terms. So x plus 2 is a common factor. So we can take this x plus 2 itself. This binomial is a common factor. So take it out, factor it out, then put parentheses. The leftovers are what? This factor y and this factor 3. So put y plus, for the second term, the leftover is 3. So when you factor this, since x plus 2, the whole binomial is a common factor, so this will be the product of x plus 2 and the leftover factors, y plus 3. For problem 3, we do the same thing because the binomial b minus 3, b minus 7, okay, the b minus 7 is a common factor because this binomial occurs on both terms. So the GCF is b minus f, so you can factor out this whole binomial b minus f with the parentheses. You have to put parentheses, and then this is a product of this binomial times parentheses, that is the leftover factors, a plus b. Okay, in this example 4, x minus 5 and 5 minus x, there is a binomial, 2 binomials, x minus 5 and 5 minus x. They are different actually, but we can make it same. Okay, let's check out this property. Here is a plus b. Okay, for a plus b, you can switch this a and b using commutative property, so this will be okay. A plus b, you can interchange a and b, so b plus a is fine. But if we have a minus, then can we switch a and b so it becomes b minus a? No, this is not right. This is not right. So, but we can make it same by doing this. Okay, if you switch a and b so it is b minus a, then you can put the negative sign outside. Then this is true. Okay, this is true. So a minus b, if you switch b and a so it becomes b minus a, then put parentheses and put the negative sign outside. Because, okay, if you simplify this, and this will be distribute, so negative b plus a. Since this is plus, you can switch a and b, then b plus a plus, this is plus, so you can switch using the commutative property, you can switch a and minus b. Then this is equal to a minus b, which is same as the original one. So this is true. So whenever we have a binomial where the first term and second term switched, for the subtraction, then we can put the negative sign. So from here, Okay, 5, this is x minus 5, this is 5 minus x. So why don't we switch x and 5? So x minus 5, then what do? We put the negative sign outside. So that's what we can do. So that we can make the same binomial. Can you see this? So switch these two. So let's use a red pen. So you can switch these two by putting the negative sign outside. Okay, x minus 5, put the negative sign outside. And then from this, the binomial x minus 5 is a common factor. So take this binomial out, put parentheses, write down the leftover factors. So 2x minus y. So we call this factoring by, well, actually it's not a factoring by grouping, but it's coming soon. So anyway, one of the method of factoring a binomial, which is already, it's not a single factor, is a binary common factor. So factor that one out. Okay, let's try this time factor by grouping, the real factor by grouping. Okay, I think I need to explain this one again because I paused and then explained this question. Okay, anyway, okay, there are 4 terms, and then these terms does not have a common factor, so no common factor, and there are 4 terms. Then we can try factor by grouping. So let's make the group of 2 terms. So the first 2 terms will have common factor y squared. And the second group will have a common factor 2. But since 6y, the sign is negative, so why don't we always take out the negative sign together? So the common factor of the second group will be negative 2. And then factor out y squared from the first group. So factor out y squared. So the leftover from the first term will be 3y. And the second term will be minus 4 because, y squared, y squared went out. Okay, for the second group, we factor out negative 2. Once you factor out negative, if there's negative as a common factor, then you have to change the sign. So negative 6y will become positive. So since 2 is out, 6y will be 3y. So when you distribute, negative 2 times 3y will be negative 6y. Okay, plus 8. So plus will become minus. And then 2 times 4 is 8. So make sure when you distribute, you should have the same expression as the original one. So from this, as you see this, the binomial factors, 3y minus 4. 3y minus 4 is a common factor. So take this 3y minus 4, then write down the leftover as another binomial factor, y squared minus 2. So if this is factorable, then from the first group, the binomial factor in the first group must be the same as the binomial factor in the second group. Always, if this is factorable. Okay, from this problem number 5a, okay, there's no common factor and there are 4 terms. So why don't we try factor by grouping? So put the first 2 groups as one group, 2 terms as one group, and the last 2 terms as the other group. So from the first group, the common factor is y cubed. The greatest common factor on the second group is 4, and that's it, 4. So we can now factor each group. So from the first group, factor out y cubed. Then y to the 5th power becomes y squared. The second term, will be, y cube went out, so we have 5, so minus 5. And from the second group, factor out 4, then y cube is the leftover, minus 4 times 5 is 20. So from this, y squared minus 5 is a common factor. If this is factorable, again, if this is factorable, then this binomial must be the same as the second group. So you can factor out y squared minus 5. Then the leftover is y cubed plus 4. So this is the result of factoring 4 terms. Okay, for the last one, okay, let's make a group of 2 terms, groups of 2 terms. So from the first group, the common factor will be 2y squared. For the last group, okay, 3 is the common factor, but since this is minus 3y, so let's make it negative 3 as a common factor. Then from the first group, factor out 2y squared. So 2y squared went out, so 1y left over, and for the second term, 2y squared. So 2y squared went out. Went out means it's not 0. 1 is the leftover. So everything's went out, they're factored out, so 1 is left over because 2y squared is equal to 2y squared times 1. So once you factor out this, actually 1 is the leftover. Okay, the minus 3 is a common factor. So y is the leftover, and the plus 3, because since we took negative sign out, plus sign becomes minus 1. Same thing. 3 is equal to what? 3 times 1. So you can take this 3 out, then 1 is the leftover. Okay, so from this, we know that y minus 1 is a common factor. So let's factor that out. So y minus 1, factor out the binomial, y minus 1, that the leftovers are 2y squared minus 3. Okay, let's try, this is the last one. All right.